Answers to the Foundation P1 test. Question 1, 1.1. Adding words from this box to the gaps in the text here. Gas boiler transfers chemical store into a thermal store. So it's chemical energy to thermal energy. Television transfers energy to the surroundings through light and sound. We could also have used heat energy or thermal energy here as well. A ball falling off a table transfers energy from gravitational potential to kinetic. So the ball is on the table, and as it falls, the gravitational potential energy turns into kinetic energy and it moves. And the catapult converts elastic potential energy to kinetic. So the elastic energy in the catapult transfers to movement energy as it is released. 1 mark for each of those. Okay, next question, hairdryer. And we have total energy input here of 800 joules. So that's the energy that goes into the hairdryer from the plug for the power source. And 500 joules of that energy is converted to heat or thermal energy. The rest is sound energy. Calculate the amount of sound energy transferred. So what we do here, we take the total energy that went in and we take away the thermal energy, which will leave us with the energy for sound. So 800 minus 500 is 300, so it's 300 joules. 1.3, state what happens to the sound energy. Well, it's dissipated. Its energy is spread out in the surroundings. 1.4, the power rating of the hairdryer is 63 watts. Calculate the energy transferred in 300 seconds. They give you the equation. So the energy transferred is equal to power multiplied by the time. So it's 63 multiplied by 300. So the answer is 18,900 joules. So 2 marks for this. 2 marks if you get the correct answer. If you did the correct working out but got the wrong answer, you get 1 mark. Okay, skateboarder in a semicircular ramp. Lots of information in this question here. So we need to be clear about the information we're looking at. So the mass of the girl is 50 kilograms. The height of the ramp is 4 meters. They give the equation for the gravitational potential energy, so it's mass multiplied by the gravitational field strength multiplied by height. They give you the gravitational field strength, 9.8 newtons per kilogram. So all we need to do is multiply the 9.8 with the 50 and the 4. In these questions, it's really important that you check you've got the right units. So in this case, the height is in meters, which is correct. The mass is in kilograms, which is correct. And the gravitational field strength is newtons per kilogram. So that's all fine. No changes needed. So 50 multiplied by 9.8 multiplied by 4 gives us a gravitational potential energy of 1960 joules. Again, the 2 marks are given for the correct answer here if you have the correct working out, but the wrong answer is 1 mark. Question 2.2. Here they're asking us to tick 2 boxes. So not all the gravitational potential energy is transferred to kinetic. Why is that? Well, some of the energy is wasted. So that will be sound in particular, heat as well. and the other one is the gravitational potential energy of the girl is not 0. Now, if we look back at the diagram, it says 4 meters is this distance from the very bottom of the ramp to the top. But the girl doesn't actually get to the very bottom, she gets to here. So she's not actually at 0 at this point. Okay, she'd have to be at the very bottom here to be 0. So that's why not all of the gravitational potential energy is transferred to kinetic. 2.3. Explain how lubricating the wheels of the skateboard can increase the speed. 3 marks for this one, so 3 pieces of information. Less energy is wasted as heat due to friction. We all know that. Increasing the friction increases the heat energy, which is all wasted. So that takes energy away from what may be converted into kinetic energy, so it will mean a slower speed. The wheels can move more freely if they're lubricated, so therefore more energy is transferred from the gravitational potential energy to kinetic energy, which means that the skateboarder travels faster. Okay, question 3.1. Write down the equation that links power, time, and work done. So command word write, they want us to write an equation that links all of these 3 things. Power in watts is equal to work done in joules divided by time in seconds. Remember, some of these equations you have to learn. They will not give them to you in the exam. And this is one of them. 3.2. To lift the bar, the power lifter does 3.78 kilojoules of work in 3 seconds. Command word is calculate the power. Okay, so we want power here equals work done divided by time. Now notice the power lifter does 3.78 kilojoules of work. Now we have to multiply that by 1,000 to convert that into joules from kilojoules, which gives us 3,780 joules. We then put that into the equation and it gives us 1,260. Again, if your working out is correct but the answer is wrong, 1 mark. Otherwise, if your answer is correct here, it's 2 marks. 3.3. What effect would reducing the time taken to lift the bar have on the power? Give a reason for your answer. So if less time is taken to lift the bar, then more power is needed. If you think about this, if you want to lift those weights faster, you're going to have to put much more power into it to lift it quicker. So let's just prove this by reducing the time from 3 seconds to 2 seconds, then putting that back into our equation. So power is 3,780 divided by 2. Remember, the last question it was divided by 3. And that gives us a power of 1,890, which is higher than the power originally. So the power increases. Okay, nearly there. 3.4. Which energy store increases the power as the power lifter raises the bar? It's gravitational potential energy. Remember, anything that's been lifted gains gravitational potential energy. 3.5. The power lifter holds the bar stationary over his head for 3 seconds. How much work does the power lifter do during this time? Well, the answer is 0 joules, because work done is equal to distance multiplied by the force or the weight. We can work out the weight, but we don't really need to do that because we know distance is 0 because he doesn't lift the bar anywhere. It's stationary over his head. So since the distance is 0 and we're multiplying by 0 here, then the answer is going to be 0. 1 mark. Okay. Hydroelectric power station. Water falls through the turbines. Movement of the turbines causes the electrical generators to generate electricity. Write the equation which links kinetic energy, mass, and speed. So here kinetic energy is equal to half times mass multiplied by velocity or speed squared. Again, another equation that you will need to remember. You won't be given that in the exam. Now, using that equation in 4.2 to calculate the total kinetic energy. So using our equation here, we put the numbers in, we substitute the numbers in. So where do the numbers come from? Well, the mass is given to us here, which is 9,000 kilojoules. And the velocity is given to us here, 30 meters per second. So substituting those numbers in, a half times 9,000 times 30 squared equals a half times 9,000 times 900, which is 4,050,000 joules. Now we convert that, because it tells us here, give your answer in kilojoules, not joules. So we divide by 1,000 to give us 4,050 kilojoules. Okay, 3 marks for this. So we have the correct working out, the correct answer in joules, and the conversion into kilojoules. 4.3, write the equation that links efficiency, total energy input, and the useful energy transfer. And it's this. Okay, energy percentage is equal to useful energy output and total energy input. Both of those are in joules. You multiply it by 100 to get a percentage. And then we're going to use that equation now in 4.4. The efficiency of the turbines and generators is 80%. So they have told us what the efficiency is. They're asking us now to calculate, so that's our command word. We're going to calculate the useful output energy. Use your answer to question 4.2. Okay, so our answer to question 4.2 is here. Efficiency equals 80%. Total energy input is 4,050 kilojoules, which we've got from 4.2. So we have 2 pieces of information. We need to find the third. So the useful energy output is what we need to calculate. So I've put all the numbers in our equation. And down here, I've just rearranged that. So we have 80 on this side. We're multiplying by 100 on this side. So to cancel both sides out, we have to divide by 100. So I've done that there. And this side we are dividing by 4,050. So on this side, we have to multiply by 4,050, as we've got there. And that gives us an answer of 3,240. So question 4.4 is a lot more demanding because you have to rearrange equations, which some of you may find difficult. But that's how it's done.